Hello everyone, let's see this question. At a particular instant of time, position vector r, velocity vector v, and angular position theta of a particle traversing a path AB are shown in the figure. Here phi is the angle made by the velocity vector with the positive direction of x-axis. Then which of the following statements are correct? So the first statement, angular velocity. Angular velocity is what? V relative perpendicular by r. So here v relative is v only because the other point is fixed. So when we take its component perpendicular to r, that component will be how much? It will be v sine of phi minus theta. That will be the v relative perpendicular divided by r. So that is correct. Then modulus of tangential component of acceleration. Now if it was a circular motion, it would have been correct because in circular motion r remains constant. So when r remains constant, when you find out the rate of change of speed, you get r d2 theta by dt square. So it is only true if the motion is circular. But this is a general curvilinear motion, so it is not true in general. Okay. So in general, what is the derivation? To do that, you'll have to assume r vector as r cap and then differentiate it. Then you'll get all the terms. You'll get Coriolis force also. You will get velocity and acceleration along the radial direction also. So all those components will come out. Let's see the next option. Modulus of normal component of acceleration is v d theta by dt. Is that correct? See, theta is the angle made by the radius vector. It is not the angle made by the velocity vector. So if any vector is there and it is rotating, okay, so suppose r vector only and it is just rotating, it is not elongating, just rotating, then in this case what happens? The change in r vector, this dr vector, the magnitude of that, okay, the magnitude of this dr vector, I'm just removing vector sign, I'll just discuss magnitude right now. So the magnitude of this dr will be how much? It will be r into d theta, because theta is very small. So what do you get? You get dr by dt as r into d theta by dt. Now this can also be written as what? Omega vector cross r vector, right? Similarly, if velocity vector rotates, then what will happen? If velocity vector rotates, then the rate of change of velocity vector dv by dt. Suppose it only rotates, it does not translate. So then the only thing that you will get is the centripetal or normal acceleration. So it will come out to be what? Omega vector cross v vector. So omega vector and v vector, since they are perpendicular to each other, so what we'll get? You'll get the magnitude as, you'll get this magnitude as simply omega into v. But what should be omega? Omega should be the rate of rotation of v vector. So omega is rate of rotation of v vector. So we have to look at the angle made by the velocity vector, which is not theta, it is phi. Okay, so that's why the option C is not correct. Option D is correct. Okay.